and welcome back to another one of Mrs. Jones' chemistry videos. Today I'd like to introduce you to some of my really great friends. They are also known as some smart old chemistry dudes that had some really great ideas. So to start out, let me first bring in Mr. Dalton. Here he is.
Well, hello there, students. I'm Mr. Dalton, and I was one of the first people to come up with the idea of an atom. My idea of an atom was tiny, indestructible particles, and it really had no internal structure. Ha ha ha! Essentially, I came up with something that kind of looked like a circle, just a sphere. So, I know it's really smart and all, that doesn't look like a very smart model, but it was. Well, hello there. I'm Mr. Thomson. I came up with the Thomson model. Some people called this the plum pudding model. And if you've never had plum pudding, well, you're dang lucky, because it's not very good. Essentially pudding with a bunch of raisins in it. And that's what my model kind of looked like. Essentially, it was a sphere of positive electrical charge, one big sphere of positive, with electrons embedded in, kind of like the raisins on that pudding. It kind of looked like this. So just imagine when you're eating your plum pudding at Christmas. It's not so great, but that's how I got my electron model. So let me introduce you to the next guest on this show, Mr. Rutherford. Well, hello there. My model came a little bit later than all the others. I decided, everybody else, nonsense. An atom has to have a small, dense nucleus, and it has to be positive. And the electrons, everybody knows that they're not in the nucleus, and I was the person to come up with that. I am dang smart. So I came up with something that looks like this. This is probably something that you've seen before, probably the atom that maybe you even think about when I say picture an atom. But if you notice, there's a nucleus in the center, and the electrons all around the outside. Let me now introduce you to my contemporary, Mr. Bohr. You may think that I'm boring because of my name, but I am definitely not. I came up with the Bohr model. I say that the nucleus is small and dense, it's positively charged, but those electrons, they're not just random. They have specific spots that they have to go to. They move in a circular orbit around the nucleus, and it's fixed. So even though my name may say it, my model is not a Bohr, and either am I. Look at that model. It's pretty awesome. Let me take you back to Mrs. Jones now.
Well, I hope you enjoyed meeting all of my smart chemistry dude friends, but there's one more model on our trip today that I want to go over, and this is the one that we look at nowadays. It's called the electron cloud model. I think a lot of you have heard about this one before, and there's really no one person that we give credit to for this model. It contains a nucleus, protons and neutrons, so everything we know now, protons and neutrons are in the nucleus, came in this electron cloud model. It also says that electrons are constantly moving. They never stop, and we can't really tell where they're at because they're always moving. They orbit the nucleus at a fixed distance, so this kind of came from the Bohr model, and we know that each electron kind of occupies its own little space. It doesn't move in and out. And electrons are more likely to be found close to the nucleus. Electrons are negative, protons are positive, so they like each other. They like to be close to each other. So more electrons close to the nucleus. If you picture this model, it kind of looks like this. Essentially, in the center of this atom is where the nucleus is, and this whole cloud around the outside is just a region where electrons are likely to be found. They're constantly moving, so we can't really ever pinpoint it, but they're just in this area. The further away that we get, the less likely we are to find electrons. The more close we are to the nucleus, the more likely we are to find electrons. So as we start going through these, think about kind of history and how we got to this electron cloud model, and we will start talking about where those electrons are at. Where are my electrons at, yo? See you later.